Hey, it's me again. We're going to go over some more problems, acceleration calculation problems. Okay, you'll see there's some useful equations. This was on part 2 of your exam. I added some more to the review, and you'll see they're just this acceleration equation rearranged. So acceleration equals the change in velocity divided by time. It's the same thing as time equals the change in velocity divided by acceleration, and change in velocity is acceleration times time. That's because division and multiplication are opposites of each other. Okay. Now, some people got confused because change in velocity just means ending velocity minus beginning. V2, the ending velocity or the final velocity, minus V1, the beginning velocity or the initial velocity. So change in velocity is in these other equations. Okay, so you were told on, let's just do the problem, Mr. Worst. Okay, and we also uses d equals 1/2 AT squared. I like to think of it as d equals 1/2 ATT. Don't tell Verizon, because it makes squaring things easier. Okay, so over here, we have our acceleration test. I went over this in the last video. I'm not going to go over that right now. So right here, let's do a problem. Okay, use the tools. An airplane accelerates down a runway at 4 meters per second squared. Just covered it up. That's not good. That's fine. For 35 seconds until it finally lifts off the ground. If the airplane was stopped before it began accelerating, how fast is it going? How fast is it going when it lifts off? Hint, calculate change in velocity. Some people got confused on this, but that just means we want to calculate the change in velocity, which we have an equation for that. Remember? That is a times t, and that's also what we were given. We were given an acceleration of 4 meters per second squared, meters per second squared. And if you don't like this squared, you can just do meters per second, because that's what it is. Meters per second squared, meters per second, same thing. And our time, 35 seconds. It's a multiplication question. Okay, so we want to find delta V, the change in velocity. The formula is acceleration times time, and that is 4 for our acceleration, meters per second squared. I hope you guys like seeing me struggle with the mouse. 35 seconds, because, you know, I feel like it's only fair for you to see us struggle too if you're having a hard time. Okay. So 4 times 35, and since I remember from my key, that is 140 meters per second. Now, how did I know it was meters per second? Well, I could have canceled over here. Seconds times meters per second. This is going to cancel with one of those. All right, I'll just do it right here. Cancel one of those. So now we're just left with meters per second as our units. But you can also look back here. We're trying to calculate delta V. And velocity has units of distance divided by time. And we're using meters and seconds here. So it would be 140 meters per second. Check. Okay, so that's a way to do one of these problems. Good, and I am screencasting. Okay, I can't roll. Oh, I got to use this tool. Well, I can use different colors too. Okay, let's do the next one. Ooh, why did some move up, but some did not? That's strange. Okay, so next question. A boat is traveling at 5 meters per second and accelerates at a rate of 3 meters per second squared. How much time will it take for the boat to reach a velocity of 20 meters per second? Hint, this is a 2-part problem. Calculate change in velocity first. We're going to embed that, okay? Because change in velocity, remember, is, if we can scroll, I can't scroll up. Oh, I'm going to mess up my thing. Change in velocity is V2 minus V1, the ending velocity minus the beginning. Cool, didn't mess it up down here. Okay, so my change in velocity, let's just do that one really quick. My change in velocity is the ending 20, and I'm going to leave off the units because why not? I'm running out of time. Minus 5. My change in velocity is going to be 15 meters per second. Now, don't tell my physics professor from college that I left off the units right here. But you could also put meters per second in there and meters per second in there. That's what you should do. Okay. We're going to go over the rest of how to do this rest of the problem in the next video. See ya.